This is the follow-up for the tools and equipment in jet testing. We're gathered here today to look at part 2 of jets. 5,000ths jet. This is a line. This is to 10 psi. The 5,000ths jet starts at 25 psi. Okay. It runs for approximately 1.5 minutes of air pressure on the tank in the 220 vessel. 1.2 minutes. 0.6 jet. 0.7 jet, then you can see how it intersects. These numbers are all approximate. They are things I've found here. This is the point of seconds. This is minutes. So here's your start point. This is like the hot crazy matrix. You ever see that? And how much crazy you have versus etc. Okay, so now that we're through that, so what you have, 9,000ths jet. 9,000ths of an inch inside jet diameter. Runs for approximately 30 seconds on a 220 vessel. The video I did regarding this, part A. This one will be labeled part B. Let's talk more about jets. Now that we can actually put a graph to this, so you can see that jet size is very relative. Okay, now on here we can see this is what we're going to call more of a traditional Coleman style, one produced by the Coleman company, where they have 25 thou. All right, from here to here. That's more of a proper. We know who makes this. We've seen this. We've talked about that. That's basically how much there is there. Okay. Any questions? Here we have Kawasaki H series service manual. Way out of print. It was for a motorcycle I had. H3. 752 stroke. Death machine. They go into a pretty good tuning. They go into definitions. What they're talking about right here is different configurations of the jet. Mikuni, etc. So here they have a Mikuni. Reverse type. This down here is the number on the jet. This right here is the cc's per minute. So if you go for a 150 in a reverse type, your flow is going to be about 340 cc's per minute, but yet your flow in a Mikuni at 150 is going to be about 135 or so. Any questions on that? You can see plainly different configurations. This is what we've been talking about. This is sort of the science of jets. You can't make it up as you go along. There's pretty much a standard procedure for these things. Now I realize liquid versus vapor is a completely different animal. Flow meter, LTEC. Nitrogen, 50 cubic foot per hour. Now you're going to see very shortly, that's at 50 psi. The psi stays the same. The gas changes. 100 plus actually for helium, cubic foot per hour. Cubic foot per hour, argon. It's gas density, that's all we're showing here. Carbon dioxide. Then we're going to kick back to nitrogen. I collect these things. I got too many welders. I actually have the wire feeder that goes with that. Real nice machine. So hopefully this clears up some of these mysteries and understandings and flow, and there's a little bit more to it. You just can't make it up as you go along. Here, what we're demonstrating very simply, when your jet is the configuration of what was shown in the spray bottle with a wide fan, that's how it's done. There's practically zero restriction, so to speak. When you move down to a longer style orifice, I mean, come on now, folks, right? you're going to get more of a narrow stream. This really does affect how a gas pressure appliance functions, especially lanterns. It has to do with the mixing and driving enough air up. So you will end up, sometimes even though the hole on this measures properly with a piece of wire, for example, you're still getting way more flow and you end up with overburn. Here, configuration, we already know. I have not tried any of the Q99s, etc., that are now on the market from the place in Washington. I'm tired of giving that place money. So I can't comment on those. I know on the 502 generators that came from Idaho, the thread on the jet is 436 instead of 448. And I don't understand the idea of that. Maybe he had a mistake, who knows. I don't know if the Q99s are or not. If they are, so that people don't have to throw the whole thing away, I can definitely offer jets in that configuration. So hopefully you got something from this. Talk to you soon.